Friends, welcome to the video. In this video, I'm going to talk about the micrometer screw gauge, which is a tool used in industries for precision. In the previous video, I had already discussed the vernier caliper. If you haven't watched that video, it is in the card, or you can get the link in the video description. So let's get started with today's video. As you can see, here's a labeling diagram of a micrometer screw gauge. Now let's understand all the different parts of the micrometer screw gauge. So let us take a look at different parts of the instrument. First of all, the anvil, which is a fixed end of the device, and the spindle, which is the moving end of the device, where the object is placed between the anvil and the spindle for measurement, as you can see here in the image. Then there is the sleeve main scale, where measurements are regularly in the range of millimeters. Then there is thimble circular scale, which is the heart of the main device, where measurements are in the range of micrometers. That's why the device is said to be as micrometer screw gauge. Before actual measurement, first of all, you have to find the least count. So how do we find it? It is a simple ratio. Identify the smallest division on the fixed main scale, typically 1 millimeter or 0.5 millimeters in our case. Next, count the total number of divisions on the thimble circular scale, usually 50. Divide the former by the latter. For example, on a standard 50-division micrometer screw gauge, the least count is 0.5 millimeters divided by 50, which equals 0.01 millimeters or 10 micrometers. To make the calculation simple, we will take the least count as 0.01 millimeters. Now I have opened the simulation here. Website link in description. Now, to get an understanding of the micrometer screw gauge, first of all, the zeros of both the main scale and circular scale should coincide, as you can see here. It means that our gauge has zero error. We will discuss errors in the gauge afterwards. Now, there is one object given here for measurement for understanding purposes. Here, as you can see, we can move the circular scale like this, so we can place an object between the anvil and the spindle. So let's place the given object between the anvil and the spindle. So first rotate the circular scale, then place the object like this. Here, as you can see, 1, 2, 3, and 4 divisions of the main scale of the gauge are clearly visible. And in this gauge, one division of the main scale measures 0.5 millimeters. You can see here as well as here also, and you can also change the value. So multiply 4 by 0.5, and you'll get 2.0 millimeters as our first measurement. And now for circular scale measurement. As you can see, 25th division of the circular scale coincides with the main scale, which is also called as reference line. So now multiply 25 by 0.01, which is the least count of this micrometer screw gauge. So you'll get 0.25 millimeters as a circular scale reading. Now add both main scale reading and circular scale reading. So 2.0 plus 0.25, you'll get 2.25 millimeters as your final reading. Here, the formula I have used is main scale reading, MSR, plus circular scale reading, CSR, into least count, LC, plus error, so 2.0 plus 25 into 0.01 plus 0, as there is zero error in this case. The formula is similar to a vernier caliper. The only difference is that here it is a circular scale reading in place of a vernier scale reading. Now let's discuss the error in the micrometer screw gauge. Here you can see 1, 2, 3, and 4. Fourth division of the circular scale is coinciding with a reference line. See if 0 of the circular scale is below reference line. The error is said to be a positive error. So now multiply 4 by the least count 0.01. You'll get plus 0.04 as a positive error. Now, let's take a random measurement by considering the error in mind and calculate the final answer. Here, as you can see, we can clearly see 6 divisions on a main scale. So, as per the formula, multiply 6 by 0.5, so we get 3 millimeters as the first measurement. Now, on a circular scale, the 29th division is coinciding with a reference line or main scale. So now multiply 29 by 0.01, you will get 0.29 millimeters. Now, to eliminate positive error, subtract it from the main measurement. So in the formula 3 plus 29 into 0.01 minus 0.04, you'll get 3.25 millimeters as your final reading. Now let's consider the negative error because 0 of the circular scale is above a reference line, as you can see here. Here you can see that after the 45th division, 46th division of the circular scale is coinciding with a reference line. So now subtract 50 from 46. Why subtract from 50? Because the circular scale has 50 divisions. You will get -4, and now multiply it by the least count 0.01. You'll get -0.04 as a negative error. Now, let's take a random measurement by considering the error in mind and calculate the final answer. Here I have taken similar measurements as before. Here, as you can see, we can clearly see 6 divisions on a main scale. So, as per the formula, multiply 6 by 0.5, so we get 3 millimeters as the first measurement. Now, on a circular scale, the 31st division is coinciding with a reference line or main scale. So now multiply 31 by 0.01, you will get 0.31 millimeters. Now, to eliminate negative error, add the error to the main measurement. So in the formula 3 plus 31 into 0.01 plus 0.04, you will get 3.35 millimeters as your final reading. I hope you all understand the micrometer screw gauge. How does it work? Least count, error, all other stuff. In future videos, I will cover different topics in physics, so stay tuned. Thank you so much for watching this video.